today we're going to cover 3-3, proving lines parallel. So take out your notes and your pen and start taking notes. We've got one learning target. I can use the angles formed by a transversal to prove two lines are parallel.
So we have a theorem today, which is a converse of the corresponding angles postulate. It states if two coplanar lines are cut by a transversal, so that a pair of corresponding angles are congruent, then two lines are parallel. This is a converse, as it states, from what we worked on in the last lesson. So our hypothesis, we're given two angles are congruent. Here we show angle 1 and angle 2 are congruent, which now tells us our conclusion is going to be that our two lines M and N, are parallel.
So we're going to use that postulate, the converse of corresponding angles postulate, and the given information to show that L is parallel to M. It's a very short proof. So the given information is angle 4 is congruent to angle 8. So we have a transversal here. And if we look at the angles, where's angle 4? It's here. Angle 8 is here. So that tells us that since those are congruent, they're corresponding angles. So L has to be parallel to M.
Okay, so let's move on to another example. In this example, again, we're using the corresponding angles postulate, and we want to show that lines L and M are parallel. This time we're given the measure of angle 3, which is here, and the measure of angle 7. And our transversal is this line here. So looking at these angles 3 and angle 7 are corresponding, which tells us that they should be congruent. If they are congruent or equal in measure, that they are going to be parallel lines. We are also given x equals 3. So take this value for x, plug it into each of those, and those values should be equal. Okay, so looking at these, we get measure of angle 3. When we plug in x, measure of angle 3 is 40 degrees. Measure of angle 7 is also 40 degrees. So we have the two corresponding angles equal to each other. Therefore, we have the two lines are parallel. Yay!
All right, so you're going to have two problems to try on your own. This first one and then the second one. So try them out and we'll go over them in class tomorrow.
Now we have the parallel postulate. And the postulate states through a point P on line L, there's exactly one line parallel to L. So as you can see here, we have point P. We drew in a light blue line here and a dark blue line. We could draw in any number of lines, but there's only one line, which would be the red line here, going through P, point P, which would be parallel to line L. And that's what the postulate's telling us. There's only one line going through a point parallel to another line.
All right, so we have three more theorems, and they're the converses of the theorems we had in the last section. So we'll go through them pretty quickly. First is converse of the alternate interior angles theorem. So sorry, Miss Aiken's trying to help me. Anyway, the hypothesis for this is angle 1 and angle 2 are congruent. And notice they have them marked as corresponding angles. So the conclusion would be that M is parallel to N. So because the alternate interior angles are congruent, we know M has to be parallel to N. Our next theorem is converse of alternate exterior angles, very similar. So it tells us that if angles 3 and 4, so angle 3 and 4 are here and here, they're alternate exterior. If those angles are congruent, then M has to be parallel to N as well. And our last one, converse of same side interior angles. So it tells us, the hypothesis tells us, if the measure of angle 5 and angle 6, so notice angle 5 and angle 6 are same side interior angles. If they're equal, the sum is equal to 180 degrees, then those two lines, whoops, I'm having a little trouble here, excuse me. Tell me what to do. There it is. M has to be parallel to N. Sometimes, you know, just like you, we have to struggle with things before we actually get it. Okay.
Well, before we move on, just notice that our conclusions are all proving the lines are parallel based on our angle relationships here. The day before we proved, given the lines are parallel, what our relationships were. So these are all the converse. Now it's time, let's try this one out. See, now we're going to find out if the lines are parallel. Okay, so here we're given the information that angle 4 is congruent to angle 8. Angle 4 is here, angle 8 is there. We want to show that lines R and S are parallel. Here's our transversal. And looking at how those angles relate to transversal, we have alternate exterior angles. So based on that, our alternate exterior angles are congruent, therefore line R is parallel to line S.
All right, this is the second example. Use the given information and the theorems that we have learned to show that R is parallel to S. So we're going to plug in X here, X here into our two equations, see what measures we get, and then figure out what postulate or theorem we can use. So what I've shown here, I plugged X equal 5 into X in my expressions. I got 58 from 2, 122 for 3. If I add them together, they're 180. So I know that same-sided, first of all, we should look. So angle 2 and angle 3 are same-side interior angles. So we know that same-side interior angles are supplementary only if the lines are parallel, and they are supplementary, so we've shown that the lines are indeed parallel.
Nice job. That's a great proof.
Thank you.
Now it's your turn to do a checkout. You'll have 2 examples also to check it out. Do them in your handouts or in your notes and bring them to class with any questions. Here's your first one. And there's your second one.
We're going to quickly run through a little proof using these postulates and theorems. So we've been given the fact that P is parallel to R and angle 1 is congruent to angle 3. So here are the parallel marks, angle 1 and angle 3. So we're going to figure out what kind of angles they are with regards to transversal, and then prove, what do we want to prove? We want to prove that L is parallel to M. So we want to prove that these two lines are parallel. All right, so first statement. We know that first statement in a proof is always what you're given. P is parallel to R. We know that because we're given that. The next one says angle 3 is congruent to angle 2. How do we know that? Well, angle 2 and angle 3 with respect to our parallel lines P and R are alternate exterior angles. So we know that that's true by the alternate exterior angles theorem. Angle 1 and angle 3 are congruent. We're given that. So that's the reason for that one. And then angle 1 is equal to angle 2. It's transitive property of congruence. So since 3 is congruent to 2 and 1 is congruent to 3, we can say that 1 has to be congruent to 2. And since we know 1 is congruent to 2, what kind of angles are 1 and 2? Hold on, let me get rid of this stuff. Well, 1 and 2 with respect to L and M are corresponding angles. So the last statement says L is parallel to M by corresponding angles, postulate or theorem.
And now it's your turn to check it out. And so come back with your questions in class and we'll go through them. Good luck and have fun.